Hi children, in that previous video what we discussed ma? We discussed about that associative property, right? In this video we are going to discuss about that distributive property. Along with that we are having that three different properties also. Those four properties we will discuss in this video. Okay, let us see that distributive property. See here, what is the condition for the distributive property? Here the condition is A into B plus C. Here A, B, C are any three rational numbers. Okay. Here A, B, C are any three rational numbers. What is that condition? A into B plus C, which is equals to A into B plus A into C. Here what we can understand from this one? Here we can observe that A, B, C are three rational numbers. Here A into B plus C. Okay, first here in that LHS place we are adding that B plus C values, right? To that value we are multiplying with A. But here come to that RHS, what we have observed here, A into B plus A into C. Okay, individual multiplication with B and individual multiplication with C. Okay, now here see that A into B plus C is equal to A into B plus A into C. Let us see one example. Here 2 into 3 plus 4. Okay, A is equals to 2, B is equals to 3, C is equals to 4. Which is equals to, here A is equals to 2, no? 2 into 3 plus 2 into 4. Just check that here both sides we will get the same result or not. Okay, let us see that LHS side. 2 into, here 3 plus 4 which is equals to 7. Okay. And come to this one. Here 2 into 7 is equals to 14. LHS value we got that 14. Okay. Now come to that right hand side value. Here 2 into 3 is equal to 6 plus 2 into 4 is equals to 8. 8 plus 6 is equal to how much ma? Finally we will get that the same result, that is 14. Okay. So here by taking that any rational number, here what we taken 2, 3, 4, those three we can consider it as integers, and in the same way we can consider those as rational numbers also, no? Okay, now here say that both sides also we are having that same result, that's why we can say that here distributive property over addition. Rational numbers are distributive property over addition. So that one satisfies or not here? Satisfies. Rational numbers satisfy distributive property over addition. Why? Because here over addition. Because here what fundamental operation we applied ma? Here we applied that addition, no? That's why here this is distributive property over addition. So rational number satisfies this or not? Yes, of course this satisfies for that distributive property over addition. So after this one we are having that identity rules. Okay, that is the role of 0 and role of 1. Okay, role of 0 and role of 1 which is related to addition and multiplication. Okay, let us see here. Okay, next we are having that role of 0. Okay, what about that role of 0 means? Here 0 is additive identity element. What we will call that? Here 0 is additive identity element. Zero is called additive identity element. Why? Because here what is the condition ma? Here A is any rational number. Okay, A is any rational number. If you add 0 to this rational number, then what you will get ma here? If you add 0 to any rational number, then again you will get the same rational number. Yes or no? That is any rational number. For example, 1 by 2 is one of the rational number, right? So to that 1 by 2, if you add that 0, then what you will get ma again? 1 by 2 plus 0. 0 means nothing. So here nothing we are adding means what is that number is given here, the same number again you will get it as the resultant. Okay, so as per this one, what we can say here, if you add 0 to any rational number, again you will get the same number itself. Okay, that's why here 0 is called additive identity element. Okay, the additive identity element is dash. What is that answer? That is 0. Okay, ma. Next here we are having that this is additive identity, no. Next we are having that additive inverse. Additive inverse. So what about that additive inverse? Already we have this concept, that is the additive inverse means here by changing the sign. Okay, for example here positive number they given means its additive inverse is negative. Okay, in that integers concept we learn about that, right? So here also one say that additive inverse of element, additive inverse of one of the rational number, let it be some a. Okay, that is a positive letter, no. Positive letter means what you will get, ma? Actually additive inverse means minus of given number. Minus of given number. Then what you will get? Minus of a. Minus of a. Minus of a means which is equals to minus into plus a, which is equals to minus a. Then as per this one, what we can say here, what is the additive inverse element, what is the additive inverse of a is, that is minus a. Okay, and in the same way here, additive inverse of minus a, then what you will get, ma? Here also same, minus of what element they given here? Minus of minus a is the given letter, right? Minus a is the some given rational number. So minus of given rational number. Then what you will get, ma, here? Minus of minus is plus a. Understood? From this one what we can understand here? Here positive they given means we will get it as a negative. Okay, negative they given means we will get it as a positive. This is called additive inverse. Understood, ma? Some examples see here. Additive inverse of additive inverse of 15. For example, 15 is there. Additive inverse of 15 is what you will get here? Minus of 15. Am I clear? Then you will get it as minus 15. Understood? And in the same way, additive inverse of minus 100. Then what you will get, ma, here? Yes, of course, that is positive only. Minus of minus 100, which is equals to minus into minus plus, which is equals to 100. Understood? So this is about that additive inverse. What about that role of 0? Role of 0 is nothing but additive identity. Okay, what is that additive identity element, ma? Additive identity element is 0. Okay, after that we are having that additive inverse. So what is that additive inverse means? By changing the sign we will get that additive inverse of the given number. Okay, next we are having that role of 1. Role of 1. So role of 1 means here that is multiplicative identity. What is additive identity? That is 0. And here we are having that multiplicative identity. Okay, role of 1 is nothing but multiplicative identity. Why? Because we will call this one as a multiplicative identity, ma. Because additive identity means if you add 0 to that any number, then you will get the same number itself. Okay, and here also if you multiply any rational number or any number by 1, again you will get the same number itself. Yes or no? 2 into 1 is equal to 2, 3 into 1 is equal to 3, 4 into 1 is equal to 4. So if you multiply 1 with any number, okay, then again you will get the same number itself as the resultant. That's why here we will call that 1 as multiplicative identity. Multiplicative identity. So tell me that any rational number, ma, here, any rational number, let it be some a is equal to 1 by 2. So 1 by 2 into 1 is equal to, again you will get the same number itself or not? Okay, that's why here what is that multiplicative identity element? Multiplicative identity element is 1. What is additive identity element? That is 0. Okay, next we are having that multiplicative inverse. Additive identity, additive inverse. Multiplicative identity, multiplicative inverse. Next one we are having that multiplicative inverse. Multiplicative inverse. So what about that multiplicative inverse, ma? Actually additive inverse means by changing the sign we will get the resultant. Here multiplicative inverse means that is nothing but reciprocal. What is that? Multiplicative inverse is also known as reciprocal. Okay, then here what is that condition, ma? See that multiplicative inverse of A is 1 by A. It's a reciprocal. Reciprocal means actually A, that is a rational number. If that a rational number is a whole number, okay, for example 2 they given means how we can write the 2 as a rational number? By taking 1 as the denominator we can express that 2 by 1. Okay, here also let it be some A by 1. A is one of the rational number, okay, by 1. It's a reciprocal means here we will get it as 1 by A by 1. 1 by A by 1 means it's a reciprocal, again you will get it as 1 by A. 1 into 1 by A, again you will get it as 1 by A. Understood, ma? Now here multiplicative inverse of 2 is, what is that answer here? 2 they given, its reciprocal is 1 by 2. Okay, and in the same way multiplicative inverse of 1 by 2 is, it's a reciprocal 2 by 1. 2 by 1 is nothing but 2 only now. Okay, that's why here what is that multiplicative inverse, ma? By changing that numerator as the denominator, denominator changed as numerator. Okay, we will get that it's a reciprocal. So multiplicative inverse is also called as reciprocal. Understood? So children, up to here totally properties of rational numbers completed, ma. Actually what is that first property we discussed about the rational number? That is closed property. Closed property, after we discussed about that commutative property. Commutative property also known as order property. After that we are having that associative property. Associative property also known as grouping property. Okay, after that associative property, in this video we discussed about that distributive property, role of 0, additive inverse, role of 1 and multiplicative inverse. Okay, ma, these all are that properties of rational numbers. Okay, in that next video we will discuss about that related concept, related worksheet. After that we will discuss about that representation of rational numbers on a number line. Okay, and in the same way how many rational numbers are lies in between any two rational numbers. Actually that is the next concept. Okay, ma, thank you all.